Okay, today we're going to convert repeating decimals to fractions. Some repeating decimals we already have memorized. We know that 0.3 repeating is a third. We know that 0.6 repeating is 2/3. We know that 0.1 repeating is a ninth. 0.2 repeating is a ninth. 0.4 repeating is, I'm sorry, 0.2 repeating is 2/9. 0.4 repeating is 4/9, and so on. So uh, I'm going to kind of show you why that is today, and we'll do some tougher ones as well, some more uncommon ones. So convert each repeating decimal to a reduced fraction. So we got 0.8 repeating. I have memorized that that is 8/9, but I'm going to show you why here. Okay, follow with me here. We're going to set up some equations and solve some equations. Here we go. What I'm going to do is I'm going to let A equal 0.8 repeating. Very simple. I just picked A because this is problem A. So A is 0.8 repeating. Now, if I multiply both sides of that equation by 10, what I get is 10A equals 8.8 repeating. So if I multiply A by 10, the left side by 10, I got to multiply the right side by 10. Now the reason I did that is because I want to subtract these two equations from each other. Check this out. 10A minus A is 9A. 8.8 repeating minus the 0.8 repeating would just be 8. Think about the 0.8 repeatings canceling out and just leaving you with 8. Now if we just take this equation that results and solve it by dividing both sides by 9, 8 divided by 9 is 8/9. And like I said, 0.8 repeating is 8/9. And I just proved that it's 8/9. And if you type 8/9 into a calculator, you'll get 0.8 repeating. And that's the idea here. We want to turn this into this. And notice right here it says A equals 0.8 repeating, and down here it says A equals 8/9. A equals the same thing both times, just one's in decimal form and one's in fraction form. Okay, part B, let's do this again. So I'm going to go ahead and say let B equal 0.72 repeat. And then I'm going to say 100B is 72.72 repeating. Now notice the difference here is that I multiplied this one by 100 because there's two decimal places that repeat, and I want to get them both on the left side. And the same thing I did as last time here. I'm going to subtract these two equations. I'll get 99b equals 72. 100b minus b is 99b. 72.72 repeating minus the 0.72 repeating is just 72. And then I'll solve this equation. Divide both sides by 99 and I'll have b by itself. I get 72 99ths. Both of those are divisible by 9. So I get 80/11ths. 72 over 99 is 80/11ths when we reduce that fraction. And type 80/11ths into your calculator. You'll see that it's 0.72, 72, 72, 72. It's 0.72 repeating. Now C is a little bit different, and we got to throw this one in here. It's 0.8 and then 3 with the 3 repeating. So I'm going to go ahead and I'm going to change this up a little bit here. I'm going to say 10 C's is 8.3 with the 3 repeating. So right off the bat, I'm going to get the part that doesn't repeat on the left. So I've got 10C. C is 0.83 repeating, but I want 10C is 8.3 with the 3 repeating. Then I'm going to make 100C, so I'm going to multiply it by 10 again, is 83.3 repeating. Because what I want is those 0.3 repeatings to cancel out when I subtract, and that's what I've got set up now here. If I just left it as C as 0.83, then I'd have 0.3 repeating minus 0.83, and I don't want that. I want 0.3 repeating minus 0.3 repeating. So I'll subtract these two fractions. I'll get 90C equals 75. Okay, 0.3 repeating minus 0.3 repeating is nothing. 83 minus 8 is 75. And then I'll just divide both sides by 90, and I'll get 75/90ths. Both of those are obviously divisible by 5. Actually, more than that. How about they're both divisible by 15? So 75 divided by 15 is 5. 90 divided by 15 is 6. So 5, 6. And again, if you type 5, 6 into a calculator, you'll see it's 0.8 with a 3 repeating. All right, so a little bit of process there. Watch it again if it didn't make sense to you. It only took 4 minutes to go through it, so if you're confused, definitely take that 4 minutes to watch it one more time. All right, so here's what we're going to do. We're going to write 33.3 repeating as a repeating decimal and then as a reduced fraction. Well, the nice thing about this one is we should kind of have it memorized. 33.3 repeating percent is 0.3 repeating. Now, I could use the process that I just used, but anytime you've got one decimal place repeating, it's that place over 9. So I can just call it 3/9, which is obviously 1/3. And like I said, we should have that one memorized. Now 12.12% repeating, that's like 0.12 repeating. And like I said over here, if it's one decimal place repeating, you put it over 9. If it's two decimal places repeating, you can just put it over 99. But that can be simplified because both 12 and 99 are divisible by 3. So 4/33. So that's a nice little hint I just gave you. If one decimal place repeats, you can put it over 9. If two decimal places repeats, you can put it over 99. Example C, a little bit tougher though. All right, last one. The theoretical probability of rolling 8 with a pair of number cubes is 0.138 with the 8 repeating. About how many times would you expect to roll 8 in 180 rolls? Well, the probability of rolling 8 is about 14%. So that's where I'm going to start. I'm going to say that 0.138 repeating is about 0.14, and then I'll take that 180 rolls and I'll multiply it by 0.14, and I get 25.2. So it's about 25 rolls. I don't need to turn that into a fraction in order to estimate this about how many times. So it's about 25 times out of 180 rolls that I'll roll an 8. Okay, that's all I've got for you today. Rewatch as necessary. It's a little bit complicated there at first, but you'll see the pattern if you just watch it one more time. All right, have a great day.